When you graph rational functions, remember that rational functions never cross vertical asymptote line, but may cross horizontal asymptote line and oblique asymptote line. Therefore, when there is a horizontal asymptote line, y equals a not equal to 0, or oblique asymptote line, you need to check where the intersection is. Before we get started, you have to factor x to the power minus 8, you have to factor like this. And when you do the zeros, x squared plus 2x plus 4, we will get the complex solution. So don't count x squared plus 2x plus 4. For domain, you will get x not equal to negative 2 and 1 because you make a denominator not equal to 0. Since there's no common factor, you will get the x equals negative 2 and x equal to 1. Roots, that is 2, 0, because only x minus 2 equals 0. Y-intercept, f of 0 equals 4. Horizontal asymptote line is not available because limits x approaches infinity of a leading term, x to the power x squared, then reduce, here's x, you will get the infinity. That's why it's not available. For oblique asymptote line, you can use long division or synthetic division. For synthetic division, root in the corner, so get the root negative 2 and 1. Then no missing power. You will get the 1, 0, 0, 8. Then only focus on the first two. Therefore, I got this 1, negative 2 is a negative 2. Then keep doing for this 1. You will get the 1, here's a 1, so you get the negative 1. Therefore, y equals x minus 1 will be the oblique asymptote line. Hole not available. Intersection of OA and VA, I plug this 2 value to this oblique asymptote line. I got the negative 2, negative 3, and a 1, 0. So on number line, we will get negative 2, 1, and a 2. 2 is a 0. Negative 2 and 1 is a vertical asymptote line. Check a 0. 0 is a 4. It's positive. Since this is all single factor, we change sign. Negative, positive, and a negative. Now we sketch this oblique asymptote line. We need these 2 points. Negative 2, negative 3, supposed to be here. 1, 0, that's over here. So we get this oblique asymptote line. Now you can sketch the graph. On the right side of 2, that's a positive. So we go up like this. But we don't know there is an intersection between oblique asymptote line and the graph. You need to check. I will set up original function x third power minus 8 over x plus 2 times x minus 1 equal to oblique asymptote line, that's x minus 1. Then I solve for x to see whether we have an intersection between oblique asymptote line and then this rational graph. Both sides we multiply by x plus 2 and then x minus 1. So we get the x third power minus 8 equals these 2. We got the x squared plus x minus 2. Then multiply by x minus 1. Then do the FOIL. You will get x third power plus x squared minus 2x minus x squared minus x plus 2. Then we combine like terms. This 2 is gone. X third power is gone. So we get the negative 8 equals negative 3x plus 2. So x equals 10 over 3. In other words, the rational function will intersect this oblique asymptote line at 10 over 3. Suppose this part is 10 over 3, then we have an intersection here. Then it will very, very close to this oblique asymptote line. The graph will very, very close like this. Between 1 and 2, that's negative. That means the graph like this. Between negative 2 and 1, the graph will be like this because it's positive. Then less than negative 2, the graph will be like this. Now we can sketch the graph on the graphing paper. We got negative 2 and 1, that's a vertical asymptote line. Roots, that's 2, 0, it's here. Y-intercept, that's 0, 4, it's here. For the oblique asymptote line, get the negative 2, negative 3, and 1, 0. So we sketch like this. Find the point 10 over 3 on the x-axis. Then you could see this will be the intersection of rational function and oblique asymptote line. Now we can sketch the graph. This is a real graph of D. For E, first of all, you need to factor. Then you got the common factor reduce. This is a simplified rational functions. So we got all this information. Just be careful for domain is go to original function to make a domain. For vertical asymptote line, you will use the simplified function. For whole, your common factor get x minus 2 equals 0, x equals 2. Then plug this into simplified rational function. So get the 2, 4 over 9 is the whole of the graph. Now we draw the number line. Then find the special number 0 using y-intercept to decide the sign. That's 2 over 5 is positive. Since this is all single factor, it's change the sign for neighbor interval. Then we sketch that horizontal asymptote line, this line. Y equals 1/2 is above this number line. Positive for this interval, definitely like this. Then this part is positive. So graph will be something like this because this is a linear over linear pattern. Now you need to plot x-intercept and y-intercept and also the whole. The whole you have to put the open circle here. Then connect all these three. You will get the graph like this. I use the f of negative 3, 1 to decide this graph. This is a real graph for E. We have a whole at x equals 2. For f, we do have common factor that's x minus 1. Domain, you have to use this original rational function. Vertical asymptote line using this simplified. And for whole, you set up common factor equals 0, plug into this simplify, you got the 1, 8 over 9. For number line, -3 is roots and -2 is a vertical asymptote line. This is a 0. Plug in 0, this is positive, so positive. For x plus 2 square, how you get this -2? I using x plus 2 square. Since this is an even power, so sign won't change. This is positive. -3 you got from x plus 3. That's why you change the sign, because it's single factor. Now let's sketch a horizontal asymptote line. That is y equals 0 means the x-axis. This interval positive, that's why graph like this, above this x-axis. And a positive over here, that is go this way. Negative go this way. No, that's not right. It has to be very close to that x-axis. That's a horizontal asymptote line. When x approaches positive or negative infinity, your graph very close to this horizontal asymptote line. So on the graph, find the vertical asymptote line, horizontal asymptote line, and all x-intercept and y-intercept, and also the whole. You can sketch the graph like this. For this one, go here. And the bottom part, you go down and then go up like this. This is the graph for f.